Hey everybody, so now we're going to continue and we're going to start off with the equation of a line assessment that we did, the linear functions assessment. So it starts off with a word problem here. It says Bella has or is paid $25 to attend her babysitting job, but then she's paid $8 per hour. And you're asked to give an equation. So this is the initial amount, and you can think of the initial amount as your y-intercept. And this is your slope. The rate is the same as your slope. So if you're giving an equation for this, it's going to be y equals 8, the rate x, the rate times x, plus the initial amount. So that's why it's y equals 8x plus 25. All right, so now you can actually use this equation to figure out how much she will earn or how much she'll make if she's working for a certain amount of time. So when you made this equation, x is actually for the hours that she worked and y is for the money that she earned. So if she's working for 6 hours, we can then substitute 6 into the equation and figure out what y would be. So working for 6 hours, we can calculate this and we see that she'd earn $73. All right, and we can go the other way around. So now we're being told that she wants to earn $100. So she wants to buy a gift that costs $100. And we want to know how long she'd have to work. So now since you're being given the money, we would substitute that in for y and then solve for our x. So we would solve that as a regular equation. And once we solve it, we get that x is 9.375 hours. So that means if she works for 9.375 hours, she would make exactly 100. Now, if you wanted to round up and say, okay, she would have to work 10 hours because that's the closest whole number that she would have to work in order to make at least 100, then that would be fine too. So you could say 10 hours and just recognize that in 10 hours, she would make slightly more than $100. All right, so now we're being asked to sketch the graph that represents the situation described on this page. So we have here that we also want to indicate the points that are represented by B and C. So B that you did and C. So the point represented here, the point represented here. So it doesn't seem like this is a coordinate pair, but it actually is because we found that when X is 6 hours, then Y is 73. So our first point is 6, 73. So we can see on our graph, labeled hours and money, that this point is 6, 73. And now going down to this point, when x is 9.375, y is 100. So that's actually our second point. X is that is y. So 9.375, comma, 100. So as you can see here, I also put a point on 9.375, comma, 100. So those are 2 points that I asked to indicate, but we actually also have a third point. And that third point is our y-intercept. It's the initial amount, and let's look back at the word problem. It's the initial amount that Bella was paid for her babysitting job. So the y-intercept, that 25, is what she had at the very beginning. And so that's how we know that that is also a point. If you did want to draw it in another way, you could actually have used the slope of 8. So we could have actually used the slope of 8 and rows 8 and run 1. So the slope is 8 over 1. Well, that's a really awkward number to draw the slope for. So we could have started at 25, rows 8, run 1, rows 8, run 1. But as you can see, this finding several points was a much easier way to deal with this particular graph. All right, so now this becomes very similar to the quiz that we did in the previous video, but that's okay. We'll go over these questions as well. And the first one is pretty simple, a line with a slope of 3 and a y-intercept of -2. And then I asked for the slope and the y-intercept. I just want to make sure that you have everything written out before you write down the equation. And just remember the equation of a line is y equals slope times x plus the y-intercept. Y equals mx plus b. So the slope is 3, that's our m, that's our b. All right, so that's why that's the equation of our line. And the next one is slightly harder. So in the next one, we have the slope, but we don't have the y-intercept. We do, however, have 1 point. x comma y. X is -1 and y is 4. So we can go ahead and plug into y equals mx plus b. So our y is 4, we put that there. Or m is 2, that's our slope, we put that there. Our x is -1, we put that there. And we can go ahead and simplify and solve for b. 4 equals -2 plus b. And now we get that b is equal to 6 when we isolate our b. So now, since we've been given that the slope is 2, and we found that the y-intercept is 6, we now have the slope 2, the y-intercept 6, and we can write our equation. Y equals mx plus b, which is y equals 2x plus 6. All right, moving on to a slightly more difficult one. We don't have the slope this time. Now we have 2 points and we have to find the slope. So in order to find the slope, we can use the slope equation, y2 minus y1, that's a change in y, over x2 minus x1, that's a change in x. So once we have that equation written out, we can go ahead and substitute directly into it. We can call it, it doesn't matter which point we call x1, y1, and which point we call x2, y2, as long as we're consistent. 1 goes with 1, 2, of course, goes with 2. So now we can plug into that equation, substitute the 5 minus 4, so y2 minus y1 over x2, which is -3, minus 2. So now we have that our slope is 1 over -5, or -1/5. So now that we have a slope, we can choose either point. It doesn't matter if you choose this point or if you choose this point, but we only choose one. And then we substitute into our y equals mx plus b formula, kind of like we did in the previous question. So because most people prefer to work with positive numbers as much as possible, I'm going to choose this point. So this is going to be my x, 2 is going to be my x, and 4 will be my y. So y, which is 4, equals m, which we just found, -1/5, x, which is 2, plus b. And if you're not comfortable with working with fractions, which you should be, but if you're not, you can go ahead and use your calculator and put this in your calculator as -1 over or divided by 5 in parentheses. All right, so once you go ahead and solve for b, you should get that b is 4 2/5. Or if you used your calculator, you should get that b is 4.4, same thing. And so since we found our slope is -1/5 and our y-intercept is 4 2/5, we now have the equation y equals mx plus b, so it is y equals -1/5 x plus 4 2/5. All right, now moving on to the next question. A line that is parallel, we want the equation of a line that is parallel to y equals 2/5 x plus 1 that passes through 5, 2. All right, so when you see a question like this, we are interested in the slope of our new line. And in order to figure out the slope of our new line, we know that parallel lines must have the same slope. Parallel lines must have the same slope. So if the slope of our original line is 2/5, y equals m, that's our slope. So the slope of the new line will also be 2/5. Now, we can then ignore the rest of this equation. All of the rest of this equation is irrelevant to us. All we needed was the slope. So now we know that the slope is 2/5 and it passes through a point 5, 2. So passing through the point 5, 2 with a slope of 2/5, we can now substitute into our y equals mx plus b equation to figure out what our y-intercept would be. So here we have y is 2 and x is 5. So 2 equals 2/5, remember that's our slope, times x, which is 5, plus b. And we can go ahead and multiply our 2/5 by 5 and we get 2. So 2 is equal to 2 plus b, and in this particular example, b just happens to be 0. So the y-intercept is 0, and we already knew that the slope was 2/5. And so our equation is y equals 2/5 x plus 0, which we don't have to write the 0. So we can just say our equation is y equals 2/5 x. All right, so similar, but slightly different. A line is perpendicular to y equals -2x plus, y equals -2x minus 5. And it passes through 2, 7. Okay, so in this case, since the lines are perpendicular, we know that perpendicular lines have negative reciprocal slopes. So the slope of the original line is -2, or you could also think of it as -2 over 1. We must change the sign, so now it changes from negative to positive, and we should also do the reciprocal or flip the fraction. So now the slope of our new line is positive 1 over 2. So our slope will be positive 1 over 2. Once we've figured out the slope of the perpendicular line, we no longer need this equation. Everything else here is irrelevant to us. All we need to know is the slope of the line we're interested in is 1/2, 1 over 2, and it passes through 2, 7. That's our x, 2 is our x, and 7 is our y. And we can now go ahead and substitute it into y equals mx plus b. So 7 is equal to 1/2 x, which is, as we know, 2, plus b. 7 equals 1 plus b, and when we isolate the b, we get 6. So now, remember that our slope is 1/2. We figured that out earlier. And this is absolutely incorrect. The y-intercept is 6. It is not 1. That was from an earlier error that I forgot to fix. So the y-intercept is 6. And so the equation of our line is y equals 1/2 x plus 6. All right, let's keep going. All right, so here is a question that involves a couple things that a few people are uncomfortable with. The first thing that a few people are uncomfortable with is the fact that this is not in slope-intercept form. So this is in another form, but that is okay because we still have a few options to work with. A lot of people are also a little uncomfortable with the t-chart, so let's talk about the t-chart also. So if our equation is in this form and we're expected to graph it, we can either change it to slope-intercept form as we've done here, and I'll show you how we did that in a second, or we can use a t-chart and we can substitute x values into that equation. So we can substitute that x value into here and solve for y to get that y value, and go ahead and substitute another x value into x right here, and once again solve for y to get that value. And you keep going, you substitute each value to figure out what the y value is in each case. All right, but the first question actually did ask us to do that. I don't have a writing utensil here, but again, in order to figure out these values, all I did was plug in or substitute those values into that equation and just solve for y. It's just a little bit of algebraic manipulation. All right. Now, part B of the question asks us to give the equation of the line in slope-intercept form. And in order to give the equation of the line in slope-intercept form, what you're being asked to do is isolate the y. So right now, here we have 2x minus 5y is 20. If you want to isolate the y, you need to get y by itself. All right, so in order to do that, I decided to add 5y to both sides. And so I brought the 5y over here, and I then took 20 away from it. So I brought the 20 over here. You could do it in a different way if you choose, but if I move that to one side and that over to the other side, you'll get that 5y is equal to 2x minus 20. From there, if I want to get the y alone, I can now go ahead and divide this by 5. But everything that I do to one side, I have to do to the other side. So I have to divide both things over here by 5 as well. So I end up getting that y is equal to 2 over 5x minus 20 over 5. And negative 20 over 5 is just 4. So we have, negative 4 minus 4. So we have y is equal to 2/5 x minus 4. And we now have it in slope-intercept form. Once you have it in slope-intercept form, it's pretty easy to tell what the slope is and what the y-intercept is. So remember, y equals mx plus b. M is the slope. The slope is 2/5. The slope is 2/5. The y-intercept, you know from or plus b here, so it's -4. So here I wrote the y-intercept as 0, -4. If you had just written -4, that would be fine as well. That is, again, where the line crosses the y-axis. Okay, so everybody loves to talk about the y-intercept, and very, very rarely do people actually talk about the x-intercept. But the x-intercept is exactly what it sounds like. It's where the line crosses the x-axis. So just the same way we know that x is 0 on the y-axis, y is also 0, so y is 0 on the x-axis. All right, so in order to figure out what the x-intercept is, we have an equation here. And since you know that y is 0 on the x-axis, we can go ahead and substitute 0 in for y in order to figure out what x is. So in order to figure out the x-intercept, again, we would plug in 0 here. So we would get that 2x minus 0 is 20. So 2x is 20, and x would therefore be 10. So the graph then crosses the x-axis at 10, 0. All right, so I asked a bunch of stuff here because I wanted to give you several options in order to graph this line. So now, okay, when you look at this equation, you don't really see a line. You see just an equation. But you have the option of plotting these points. One point is -2, negative 4.8. -1, negative 4.4 is the next point. The third point is 0, negative 4. The fourth point is 1, negative 3.6, and so on and so forth. So you have the option of plotting those points. Or you have the option of plotting the y-intercept and doing the rise over run. So starting at -4 on the y-axis and rising 2 and running 5. That's the most common way, the way I know that you guys love to do this. And there is actually a third option, and the third option is using the intercepts. So we know that the graph will cross the y-axis at -4. It will also cross the x-axis at 10. So we can use those 2 points and draw the line. We have so many options. So let's take a look, and let's look at it in 2 ways. Let's first look at it as the y-intercept is -4 and the slope is 2 over 5. So we would start at -4, go up, rise 2, run 1, 2, 3, 4, 5. That is our second point. If we wanted to go again with the rise and over the run, go up to 1, 2, 3, 4, 5. And as you can see, we have a straight line. All right, that's one way to do it. I think that's the preferred way, but I want to show you using the x-intercept and the y-intercept. The y-intercept is 0, -4, or it crosses the y-axis at -4. That's 1 point. It crosses the x-axis at 10. That's the other point, and we could have just drawn the line straight through. Or, if you wanted to be absolutely sure, we could have gone ahead and plotted those points. For example, I'll just pick a random one. 1, negative 3.6. If we had plot that point, 1, negative 3.6, as you can see, it is in fact a point. So this question, the purpose of this question was to show you that there are several ways to get to the same answer. And you should be comfortable with all of them so that you can double check yourself. All right, let's keep moving. All right, here we have a line. The equation of the line is y equals 2 over 3x, plus 1. That's the slope, 2/3. By now you should be super used to this. And the y-intercept is 1. All right, and as you know, you could also say 0, 1. And so now to sketch the graph, we can start with the y-intercept of 1 and rise 2 and run 3, and that's the second point. All right, and in this case, in this question, I wanted you to practice using the t-chart again. So we went ahead and we plugged in our -2. So I showed a couple because I wanted to just be absolutely sure. So we plugged in our -2 and then plus 1. And so we got when x is -2, y is a -0.333. And as you can see, when x is -2, y is in fact, it does look like -0.333. And when x is -1, I substituted that into our equation and I got that y would be 0.333. And it does look, in fact, like when x is -1, y is 0.333. And I kept doing that. 0 goes with 1, 2 goes with 2.33, 1 goes with 1.67, sorry, 2 goes with 2.333, and so on and so forth. So as you can see, again, there are multiple ways to graph this line. And I said yes, because I know I'm right, because I did it 2 ways and it worked. Okay, so this was the last question on this assessment. Before, it was probably extra credit, but this time it is not. You should definitely know how to do this. So we have here that Julia is trying to decide between 2 cab companies. One has an initial charge of $2 and then charges $3 per mile after. So it starts off at $2 and then it goes 1, 2, 3 over 1. So for every mile, so as you can see, the miles are on this axis. For every mile, it charges $3 more. So there we go. Starts at 3. Let's read this again. Initial charge of 2, sorry. So it starts at 2, then it goes up 1, 2, 3 per mile. 1, 2, 3 per mile. Again, 1, 2, 3 per mile. That should be hitting right here. Okay. Now the other cab has an initial charge of $3.50 and then charges $1.50 per mile after. So it starts off more expensive. It starts off here at 3, and then the slope is 1.5 per mile. So I'm going to go up 1. Let's see. So it starts at $3.50. So this is a little bit awkward. 1.5 over 1. Okay, wait, let's make sure I'm right here. The other has an initial charge of $3.50 and then charges $1.50 per mile after. Okay, so $3.50 is here. Then we go up to 5 and over to 1. Right, so that's over to 1. I think I was counting wrong before because 1 is actually bigger than I thought it was. But you get the point. So it starts at $3.50, then goes up $1.50 and over 1. Now, what's this question asking? It's asking to give Julia some advice. Well, the thing is, the advice isn't straightforward. Which cab should she choose? She's trying to save money. Well, if she's going a short distance, the second cab is more expensive. As you can see, she starts off paying more money. But if she's only going a mile, then it doesn't matter which cab she chooses, because as you can see here, that point of intersection, she's paying the exact same amount for both cabs. Then they switch places, and then cab 2 actually becomes cheaper than cab 1. So my advice to her is, if she's taking a short ride under a mile, cab 1 is better. But if she's taking a long ride over a mile, cab 2 is better. And then for 1 mile, pick whichever one comes first. All right, and that's it for that assessment. Okay, so now we're going to go ahead and start looking at how to do these solutions, graph these solutions. So I'm going to stop this video here because I would like to pull up my calculator if possible.